Hello, Kalpagesh. Hello.
Ma'am. Yes, ma'am. Namaste, ma'am.
Yeah. Good evening.
Yes,
Can you
good
switch
evening.
on your camera for a while, please?
Yes, ma'am. Just a minute. Just 2 minutes.
Sanjay, how are you?
All fine. Sorry, ma'am, I was not in the office because
So now did you get to watch the recording of what I taught?
yes, ma'am. Yes, ma'am.
So if you have any doubts, I have
Sure,
kept
ma'am.
one extra
Okay.
session on alkyl halides today so that any doubts that you all have, we can discuss those.
Okay.
Kalpagesh, how are you? Please switch on your cameras, all of you.
Okay.
Yeah, Kalpagesh, how are you? Hope you have
Yes, ma'am.
completely recovered from your chicken pox.
Yes, ma'am.
Yeah, no weakness now.
No, ma'am.
So could you also watch, because you know this is the first chapter in organic chemistry, Kalpagesh, and you have missed those 4 classes initial. So I suggest that you go through the recording, and if you have any doubts, you can, I don't know whether I'm supposed to share my phone number with you, but I will ask the coordinator. If she agrees, then you can connect with me and I can clear your doubts, whatever you are, because I am a little concerned because everything, the further organic chemistry is depends on what you learn in alkyl halides, right? So you should please make an effort.
Ask me.
So what I would like you to do is look at the recording and make your notes, right? And then go through the textbook and keep making points about what you did not understand. Okay, so that we can do that. Okay. Hello, Vaishnavi, Hariharan. Today the other Hari Raghav has not joined us yet. He might join. Sanjay, did you get the assignment, Sanjay? Sanjay, you are one person who always keeps the camera on. Now, why is your camera off today? The S
1 minute.
is very beautiful. The S of your DP is very beautiful. Very nice font. So, Vaishnavi, I went through the assignments that you have done. You have done assignment 1 and 2, and there is another assignment number 2 which you have not done, isn't it? So there are, there's a little confusion about the numbers of assignments. I will request the coordinator to rectify that. Hari Raghav and Hari Haran both have done one assignment. Assignment number 2 of Hari Raghav and Hariharan is similar. Vaishnavi, your assignment is a little different. Actually, the 2 assignments, Vaishnavi, that you have done, they are the ones which I had sent. And I don't know whether Hariharan and Hari Raghav have done those those other 2 assignments. So if you have done, then you can upload those also. So a little bit about how your assignments are. I have gone through them. I will actually correct them and send them back to you so that you know what your mistakes are. So first thing is Vaishnavi, the assignment that you have done, the neatness with which you have done it, your handwriting, your expression, everything was very good. I liked it. very neatly, and it is most of the things that you have written are very good, correct. You still have a problem with addition of HBr. Okay, so when you see HBr, you imagine peroxides. It's not peroxides with HBr always. So just take care of that. When I send you the corrected assignment, you will understand what I am saying. Okay. And Hari Raghav,
Yes,
you
ma'am.
have done Hari Raghav, you have done it very well. Most of your answers are correct, and it was very well done. I will return yours also, and Hariharan, yours also is very good. All the answers that you have written, most of them are right. And only thing is, I would just request you to, make a little effort, because right now there's no hurry to do the assignment. So make a little effort towards avoiding a little overwriting and a little bit of neatness in the way you present your things. Otherwise, your concepts are quite good. Everything was fine. Sanjay, you have to still do the assignments, right? You have to do it.
Yes, ma'am. Yes.
Yeah. So because, I
Yes,
don't
submit
want
it
to
within-
pile up things, you should continue, do it regularly, then only you will be able to. Okay.
Yes.
So Hari Raghav, I already said that your assignments were very good, very well presented,
Yes, ma'am.
and most of your answers, in fact, almost all your answers were perfect, and it shows you have understood it very well. And soon, I think in the next week, we'll put up a test, so we'll know exactly how you are doing. And Kalpakesh, don't worry, we will make up for it. Whatever you have not been able to do, we will make up.
Okay, ma'am.
Yeah, anyway, from tomorrow, I'm going to start a new topic, so you can, that topic, there'll be no problem. In which school are you studying?
Ma'am, DAV Public School.
DAV Public School.
Hmm.
So what,
Yes,
have the school going on now, or is it holidays?
No, ma'am, it has started. They have
It
started.
has started. Which topic did you start? Solutions or alkyl halides?
Alkyl halides.
Oh, they started. So everywhere they started with alkyl halides. Only somebody was doing, no. Hari Raghav, your school hasn't started yet? Hari Raghav? Is there a delay in what you hear, Hari Raghav?
Ma'am, alkyl halides. Same subject.
Alkyl, oh, and Sanjay, what about you?
Hello, alkanes and hello, alkanes. What
Oh,
they start.
so all of you are doing the same. And Hariharan, your school, they have finished alkyl halides, or they are still doing
Yes,
it?
ma'am. Yes, ma'am. Finished, ma'am.
And what-
Hello, arrange
now-
and other things, ma'am.
And then what are they going to start next? Any idea? Solutions?
Only after summer holidays, ma'am. Exams will be coming, ma'am, next week.
Oh, so your only one topic, and now your vacations have already started, is it?
In about 2 weeks, ma'am.
Okay. Okay. So let's see. So if for your exam, you have only alkyl halides?
Halo alkanes and halo arenes, ma'am.
Okay. 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 Okay, so today I'm taking this extra class so that, we can do a few more questions so that you can become more thorough with haloalkanes and haloarenes, because this topic is very, very important, because once you understand this, then alcohols is very easy, and rest of them will not take so much time in understanding. Okay. So today I plan to do a few conversions, because doing conversions, converting one compound to the other, that is the best way to understand all the reagents, and to remember and to memorize and to recall. All those things happen very easily. So I'll share my screen now.
Ma'am,
Yes.
ma'am, I have a doubt in that elimination reactions part, ma'am.
Okay. Okay. We can do that elimination reaction also. But
Yes, ma'am.
I think you wrote the correct answer though.
Ma'am, yes, ma'am, for that question, okay, ma'am. But in that book, they have given a statement like In dehydrohallucination reactions, the preferred
Hmm.
product is that alkene, which has the greater number of alkyl groups attached to the doubly bonded carbon atoms. Further, they have
Greater number of
given an
alkyl
example.
groups.
Ma'am. I could not understand it.
Okay, I will just. So you are talking about not is it dehydrohalogenation or addition of HCl? I can't hear you. You are on mute.
From dehydrohalogenation.
Okay, so can you name the compound for which you are talking about? Can you please name it?
2-bromopentane.
2-bromopentane. So pentane, this is pentane, and this is Br, right? 2-bromopentane. So you have to do dehydrohalogenation of 2-bromopentane, right? Using alcoholic KOH.
Yes, ma'am.
Right. So what is the product they are saying?
Ma'am, they have given two products, pent-1-ene and pent-2-ene, and
Yes.
pent-2-ene is the major product.
Pent-2-ene is a major product. So when we did dehydrohalogenation, I gave you one rule. I told you, see, poor becomes poorer. Okay, that's an easy way of remembering. However, the name of the rule is Sedzev's rule. Sedzev's rule. What does the Sedzev's rule say? It is somewhat like Markovnikov's rule only, but it is a rule for elimination. So it says that hydrogen is always eliminated. This type of reaction, it is called beta elimination. Beta elimination means the beta carbon is the carbon which is this carbon where halogen is alpha, and the adjacent carbon is beta. Now there are two adjacent carbons. So the carbon in the third carbon here, let us number them. 1, 2. Let me number it from the correct side. 1, 2, 3, 4, and 5. Right. So these are the carbon atoms. Here I should write H also. So halogen will definitely go from here. Now, will the hydrogen go from this one carbon at number 1 or the carbon at number 3? Where will the hydrogen go from? So this is, if you remember, poor becomes poorer. It becomes easy because this carbon is rich. Why? Because it has 3. This carbon is comparatively poor because it has only 2 hydrogens. So hydrogen will go from here. So if a hydrogen goes from here, then what will it become? CH2. And CH double bond CH, CH3. So this will be the major product. All right, Vaishnavi?
Yes, ma'am. Understood, ma'am.
Now, supposing I have, just tell me one more, CH3. And here I have CH and CH Br and CH3. Now, can you tell me what will be the product of dehydrohalogenation?
Ma'am, CH3, C double bond, CH, Br, CH3, and in the second carbon, there will be a CH3.
So the CH and CH3. All right, the double bond will be here because bromine will anyway go. Then will hydrogen go from carbon 1 or will it go from carbon 3? It will go from carbon 3 because it has less number of hydrogen atoms. Okay. So,
Yes, ma'am.
okay, so now we are going to do a few conversions today. Now the first conversion that we are planning to do. Okay, so we will okay, so benzene to 4-bromobenzene. Okay, so I will write first one here. This is the first one. Benzene, I need not write that. I will just write the structure directly to save place. Okay, and I will take you all on the left. Okay, so benzene to 4-bromonitrobenzene. It is 4-bromonitrobenzene. So what will you do? First, you will make it nitrobenzene. And what is 4-bromo? 1, 2, 3, 4. 4-bromonitrobenzene. Okay, you have to bring about this conversion. How are we going to do it? Any idea? Anyone? What will we do? Hari Raghav, tell me what we will do. First step. Now, children, remember when we are doing conversions, you should remember we need to write only the major organic product. We don't need to write any byproducts and only the reactants on the arrow. And then we can continue one after the other. If you write the byproducts, then you cannot, then you will have to write separate equations. So if you want to write in the same line, then it is better to write only the major product, not everything. Now here on the benzene ring, I have to introduce NO2 and
We need to add bromine in the presence of
yes,
Fe
very good.
catalyst.
Yeah, so in the presence of Fe catalyst, we will add bromine. Okay, you can take Fe or we can also take FeBr3. Even if you take Fe and bromine will combine to form FeBr3. So you can write FeBr3 and bromine or Fe and bromine, both are same. So Vaishnavi, why did you choose to do bromination first and not nitration? Can you tell me?
Ma'am, because this is addition reaction, ma'am. So first we need to add bromine.
This is not addition reaction. This is a substitution on the benzene ring. Okay, so you have put bromine in place of hydrogen. Remember, it is an electrophilic substitution reaction. When I write the reaction like this, say benzene is C6H6. When I add bromine to it, bromine is not added. It replaces one hydrogen. So what is the product? C6H5Br plus HBr, right? So bromine is coming in place of a hydrogen. So this is a substitution reaction, but you chose the correct step rightly. I will explain to you the answer. Now, what is the next step? Hariharan, can you tell me the next step?
Ma'am, we'll add H2SO4 and HNO3, ma'am. H2SO4 and
Yeah,
HNO3.
H2SO4 and HNO3. Remember, you know the
We need NO2
concentrations
plus,
are,
ma'am.
yeah. So this is you have to write the concentration. This is also concentrated and this is also concentrated. So if you take concentrated H2SO4 and concentrated HNO3, then nitro group will come on the ortho or para position, right? Now Br does not, it will not come on both. It will come only on one because Br, like chlorine, also deactivates the benzene ring. Okay, so para product is a major product. So you will get here NO2. So I got this product. Okay, now my question was, why didn't I do nitration first? Vaishnavi decided to do bromination first. Why did she? It was a correct move. But if I did nitration first, what would have happened? So I would take, say, for example, I will take benzene and I will do nitration first. So I will do this step, H2SO4 and HNO3 concentrated. What will happen? I will get nitrobenzene first, right? And then if I do bromination, Br2 and Fe, what will I get? Tell me. What will I get? Hari Raghav, oh, all have, tell me. Hari Raghav has not answered today. I think your...
Ma'am, will it be ortho, ma'am?
No. What is the directive influence of NO2 group? NO2 group is meta directing, right? So if I put NO2 first, what will happen? Br will come on the meta position. So I will not get 4-bromo-nitrobenzene. I will get 3-bromo-nitrobenzene.
Okay.
Did you understand? So you have to plan your synthesis based on the, all these small things you should remember. Now you may sometimes forget what is the directive influence of different groups. So I will tell you a trick to remember directive influence. Okay, so to remember the directive influence, that means the group which is already present on the benzene ring, how does it decide where the next substituent will come on the benzene ring, right? So there are groups like Cl and OH and NH2, right? And Br and OCH3, right? All these are ortho-para directing, right? So if any of these group is already present on the benzene ring, then the new substituent will come on ortho or para position with respect to the substituent that is present. So that is rule number one. What is rule number two? Rule number two is groups like CH double bond O, right? C double bond O and OH and N double bond O NO2. It is written like this, NO2, or C double bond O CH3, right? These groups are meta directing. Now you don't have to learn which is ortho-para directing and which is meta directing. If you know what is the group, you just look at the bonds in the group. Now you see Cl anyway is a single one. Here O and H bond is a single bond. NH bonds are all single bonds. Br is anyway single. O and C bonds and C and H bonds, they are all single bonds. So if your substituent has all single bonds, only single bonds, then it is ortho-para directing, right? Then it is ortho-para directing, right? And if your substituents in all these on the second one, what can you see? You can see that there is a double bond everywhere. Here there is a double bond. 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 So if the substituent present on the benzene ring contains a double bond, then it will be meta directing. I hope you understand the meaning of ortho-para directing and meta directing. All right. So if I have a substituent here on the benzene ring, right? If I have something here on the benzene ring, like for example, if I have NH2 on the benzene ring, or it's not the right example. Right? I have not written that group here. If I write CH3, then tell me whether it will be ortho-para directing or meta directing. Any one of you. Will CH3 be ortho-para directing or meta? Huh?
Ortho-para.
Ortho-para, right? Because why will it be ortho-para directing? Because this is how CH3 is. In CH3, all bonds are single bonds. So it will be ortho-para directing. This is not the reason why it is ortho-para directing. This is only a way to remember. The reason is only based on the resonance structures and so many other things, but this is the way to remember. Okay, so if you can remember that if there are single bonds, the substituent ends up as ortho-para directing. Now supposing I have this one here. I have not written this group. Now I am asking you, you tell me, is it ortho-para directing or meta?
Meta.
This will be meta. This will be
Plus double bond.
meta. And this is ortho para. So if there is a double bond, then it is meta. If it is all single bonds, then it is ortho para direct. Okay. Now let us do the next question. And the next question is benzyl alcohol. Now let me write here. Benzyl alcohol. This is first you should be able to write the reagent correctly. Alcohol, and I want to convert it to what? I want to convert it to 2-phenyl ethanoic acid. So this is CH2COOH. Okay, so this is benzyl alcohol and this is 2-phenyl ethanoic acid. Did you get the structure right? Now, how would we do? Anybody? Any guess? Now, first, whenever you start with a conversion, you should carefully see, compare the two, right? And when you compare the two, the most important thing that you should look at is the number of carbon atoms. Okay, you should look at the number of carbon atoms. Now, in the product, there is one carbon atom more. Here, there is benzene ring is attached to only one carbon atom. Here, the benzene ring is attached to 2. So now here, what is the challenge? I need to increase the number of carbon atoms, right? So how do I increase the number of carbon atoms? For increasing the number of carbon atoms, you should always think of cyanide, because when you add a cyanide, then what will happen? You are increasing the number of carbon atoms. So now, how can I bring in a cyanide in place of OH? I don't know how to do it, but I know how to do it if it is CH2Cl. If it is CH2Cl, I know how to change Cl to Cn. So first I will need to do what? I need to change OH to Cl. How can I change OH to Cl? Tell me. Anybody? Sanjay, you were there in the beginning. Can you tell me? Sanjay, is he there?
Yes, ma'am.
Yeah, tell me, Sanjay. Anybody else? Hariharan, you tell me. You have a test coming up. Tell me. How can I convert an alcohol into an alkyl halide? Method of preparation. Which reagent? You are muted. Tell me. There are 5 reagents which we can use. You remember? I told you they are called halogenating agents. The most important which you should not forget is PCl5. What does PCl5 do? It changes OH to Cl. Okay. Now this everyone will remember. I want to replace Cl with Cn. How can I do that?
KCN, ma'am.
KCN, very good. Potassium cyanide or sodium cyanide, you can do this. And there is another very useful reaction which converts Cn to COOH, that is by adding H2O and H+. Always remember, when you hydrolyze a cyanide, hydrolyze means react any cyanide with water, then Cn changes to COOH. So this is a very special thing that you need to remember. So if I have C triple bond N and I add to it H2O and H+, Cn is replaced by COOH. This is the best way of converting cyanide to COOH. Now you might wonder why and how. So I will tell you so that you remember it easily. So now you have C triple bond N. Yes? Yes?
Ma'am, rather than PCl5, can we put HCl and what? CHCl?
HCl and what?
Ma'am,
HCl and
can't we do
zinc
just
chloride.
with HCl?
No, we cannot do with
Okay.
just HCl, right? Because you need to, to remove OH in case of alcohols. HCl is a strong acid, so a weak acid cannot displace a strong acid. So you will have to use concentrated HCl along with zinc chloride. Then only you can do it. Okay.
Okay. Yes.
Some reactivity we have to keep in mind. Okay, so CH3CN. Now, supposing I have this cyanide, CH3CN, and I add to it water, HOH. Okay, now there is a triple bond here, where what is nitrogen? It is slightly negative and carbon is slightly positive. What about hydrogen? It is slightly positive and oxygen is slightly negative, right? Now you have negative, positive, positive, negative. We can add. So let us add hydrogen to nitrogen and OH to CN. So if I do that, what will I get? CH3, C, this will become OH. And I have added something, so double bond will change into, triple bond will change into a double bond. So I will get this product, CH3, C, OH, and NH. All right, CH3, CH, OH, and NH. Now what happens is this compound that I have written here, I'll take another slide. So I made CH3, CH3COH double bond NH. Okay. Now this compound, there is some rearrangement. So what is the rearrangement? H is attracted by this lone pair of electrons of nitrogen because oxygen is more electronegative. So it doesn't anyway, love the hydrogen as much as comparatively nitrogen is better. So it decides to go there and this double bond shifts here. So as a result, I will get CH3, C double bond O and NH2. All right, so this what you got here is an amide. Now I will add one more water molecule, HOH, right? Always when there is a water molecule, you write H plus and OH minus. The purpose of adding acid here is always so that water ionizes like this. Here, what is nitrogen? Delta negative, and what is carbon? Delta positive. Now you can just, again, this OH will break the bonds now. So what will happen? H will come here and OH will come here. So as a result, what will I get? CH3, C double bond O, and here OH plus NH3. Right? And this NH3 will not react with this acid. In fact, it goes and reacts with the H plus and forms NH4 plus. So that is why the ammonia is neutralized by the acid. So we use H2O and H plus. So if you have understood this, this is just to make you understand how the reaction works. But you need to only, when you are writing conversions, only you will come across this reaction. Nobody will ask you otherwise. So you should always remember, if I write H2O and H plus, the CN will change into COOH. Okay, CN will change into COOH. So the trick is the reagent converts this to acid. So this you should remember. Now let us do the next one, the third one. So what is the third one? Ethanol to, let me not write it this time. Ethanol, what is ethanol? CH3, CH2OH. 2-propane nitrile. What is propane nitrile? CH3, CH2CN. Okay, so all that which I was trying to explain to you, you can now answer with the help of that. Somebody should tell me, how will I convert alcohol to propane nitrile? First, you should remember this name. This 3 carbon atoms in a chain, so it is propane, and CN, the suffix is nitrile, so it is propane nitrile. The common name of this compound is ethyl cyanide. Ethyl cyanide and propane nitrile, they are the same. So don't get confused. Now, who will tell me how to do
Ma'am.
this one? Yeah, tell me.
Ma'am, first we add SOCl2, ma'am, for PCl5. ma'am.
SOCl2. Very good. Or PCl5, anything you can. CH3,
Then we add
CH,
KCN, ma'am.
very good. So first I add SOCl2, very good. And then I add potassium cyanide. All of you seem to love potassium cyanide. You can
Ma'am, in
use
the
sodium cyanide. Yes, tell me.
Ma'am, in the first step, we can use PCl5 also, right?
Yeah, SOCl2 or PCl5 or PCl3, anything you can use. Okay. Here I cannot use zinc and zinc chloride and HCl because at room temperature, this is a primary alcohol, it will not react. So it is safest to use PCl5, PCl3 or SOCl2. All of them are very strong halogenating agents. That means they will replace OH with Cl wherever it is. Okay, now the next is aniline to the fourth one. It is aniline. Aniline is this one, NH2. And I have to convert it to chlorobenzene. This is the last method of preparation of aryl halides that I taught you, if you remember. Now, what does aniline? Aniline you can't replace the NH2 group directly with Cl. Okay, but in between there is a very interesting compound that you can make, and that compound is N2 plus Cl minus. This is known as benzene diazonium chloride. Okay, it is a salt, right? Benzene diazonium chloride, and I told you this is a very useful compound because whenever you are doing conversions in alkyl halides or haloalkanes, then you should try to reach alkyl halide. You know, you saw in most of the conversions, we are reaching the alkyl halide. Here, similarly, in aromatic conversions, you should try to reach benzene diazonium chloride. Now, the question is, from aniline, how do I make benzene diazonium? That is with NaNO2 and HCl, that reagent. And very importantly, you should write 0 to 5 degrees. If you don't write the low temperature, then you will not get this, you will get phenol. So I don't want phenol, I want benzene diazonium chloride. And then we do the Gattermann reaction or Sandmeyer's reaction. So Sandmeyer reaction is Cu, Cl and HCl. So it will, this N2Cl will be replaced by Cl. Okay, so these are doing the conversions that helps you in revising all the reagents that we have. So this is a new important reagent, remember, which can convert aniline to benzene diazonium chloride. At the end of this class, we are going to write all the reagents, a list of all possible reagents and what do the reagents do. We will do that. Okay, then the next one is 2-chlorobutane. So butane, 2-chlorobutane, CH3. CHCl, CH2, CH3. And from here, what do I have to make? 3,4-dimethyl hexane. So I need to make let me write it in a particular way so that you all can immediately understand what we have to do. CH3, CH, CH2, CH3, and CH, CH2, CH3, and here CH3. Right? So did you see your product here is 2, 3. 3, 4, 1, 2, 3, 4, 3,4-dimethyl hexane. And this is 2-chlorobutane. Anyone who can answer this question? Vaishnavi, can you answer?
Ma'am, I'm thinking.
Now you look at the left and the right. What has happened here? The number of carbon atoms in the product are double the number of carbon atoms in the.
Ma'am, addition of sodium.
Yes, sodium. Sodium and dry ether. Do you remember the name of this reaction? We will have to write this 2 times. Okay, 2 molecules of this will combine to give you this one. So what is the name of this reaction where we make it double? Starts with W.
Roots
Right?
reaction.
Woods reaction. Woods reaction. Right? Woods reaction. Very good. Okay, so simple one step. So 2 molecules of 2-chlorobutane will give you. Very good. Now we will take 2-methyl 1-propene. 2-methyl 1-propene. So CH3, CH. One propane. 2-methyl 1-propene. Right? And from this one, we have to make 2-chloro-2-methyl propane. Propane. Now, this is the conversion that we need to do. Now, if you watch carefully, the carbon skeleton has not changed. On this side, 3 carbon atoms in a chain. On the second carbon, there's a branch. Here also 3 in the chain. On the second carbon, there's a branch. Now, how can I do this? From here to here, how can I do this? Can I do it in a single step? Yes, addition of HCl. Just add HCl, you will get the product. Okay, so sometimes the reaction is so easy as this one, but you have to make an effort to think. The more you think, the more answers you get, the more exciting it will become. Now the next one also you should be able to do. Butene, where is it? Ethyl chloride to propanoic acid. CH3, CH2, Cl2, CH3, CH2, COOH. So now you look, compare the left and the right. How many carbon atoms I have increased in the product? Product has 3 carbon atoms and my starting compound has only 2. Sanjay, can you think and tell me what is happening here? What can I do? How can I increase 1 carbon atom? I just did one question like that, the first one. How can I increase the carbon atom here?
I think HCl will work here also.
We don't use HCN. Remember, for converting alkyl halide to cyanide, instead of HCN, we should use KCN or NaCN, right? Why should we use? Yeah, because HCN, it does not ionize easily. HCN we can't use. Okay, so best is to use potassium cyanide or sodium cyanide. Now, when you use this, what will happen? You will get CH3, CH2, CN, right? And Kalpakesh, although you didn't attend my earlier classes, but this part I taught you just now. How can I convert CN to COOH? Just look in your notes that you are writing. The previous one I was showing you the reagent which can convert CN to COOH. What is that reagent? Hari
Don't
Raghav?
know.
See this. Hari Madhavan, just look up. See this. So what is the reagent I am using to convert CN to COOH? What is the reagent?
H2O or H plus.
Yes, so you have to remember that. So
Okay.
what will I write on the arrow? H2O and H plus.
H plus.
Okay, H2O and H plus. Okay. Now let us do the next one. दादा को बोलो. Then the next one is ethyl but 1 into N-butyl iodide. Okay, so but 1 in CH3, CH2, CH double bond CH2 to N-butyl iodide. We should write the structures correctly. CH3, CH2, 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 and I. Okay. Now what I need here is iodine on the first position. Now Vaishnavi, please pay attention here. This is the place where you are making a few errors, so you should remember this one. Now here, what do I want now? I want I on this carbon, which is rich, right? I cannot add HI because HI does not follow the anti-Markovnikov rule, or it doesn't have peroxide effects. But I know a method by which I can add HBr with peroxides. Okay. So when I add HBr with peroxides, what will I get, Vaishnavi? Because there are peroxides, I will get CH3, CH2, 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 and I. I will come on the not Br, sorry. Br will come on the terminal or the last carbon, or that carbon which has more number of hydrogen atoms. So it is anti-Markovnikov's rule. I could not have added HI with peroxides because peroxides have effect only on HBr. It doesn't have any effect on. So I will first add HBr. Now, how can I replace Br with I?
And by adding
Okay.
HI.
Not by adding HI. There are two things you have learned: Schwarz reaction and Finkelstein reaction. Okay, so it is a Finkelstein reaction. So you take AgI. Okay, so if I take AgI, this is called halogen exchange. That means Br is replaced by I. What is the reaction? This is called Finkelstein reaction. Finkelstein reaction. What is the Finkelstein reaction? This reaction is used specially to make iodides. I told you how to remember this. This reaction name begins with F, but it is not for making fluorides. It is for making iodides. So there are two such reactions. One is Schwarz reaction, SWARTZ. Schwarz reaction. What does it do? It changes the halogen to, so here the final product is iodide, and here the final product is a fluoride. You are removing the halogen and replacing by I. Here you are removing the halogen and replacing by F. Okay. Now the next one here is 2-chloropropane to 1-propanol. So this is 2-chloropropane, let us write. So CH3CH, CH2, no, CH2-chloropropane, to 1-propanol, CH3, CH2, CH2OH. How will I do that? I have to not only remove Cl, but I have to attach OH on the terminal carbon atom. All right, so what will I do? Now, the first thing that you can do is first you remove this HCl, right? Now, Vaishnavi, tell me, how will I remove it? What is the method of removing? Dehydrohalogenation. So if I do dehydrohalogenation, what will I get? Propene, right? Which reagent will I use? Alcoholic KOH, right? Now with alcoholic KOH, children, if I were in a regular class and you are sitting in front of me, I would not have given a single answer. I would have made you all do it, right? Now in 1.5 hours, I don't get to see you, but I need to just quickly do it. So please keep actively. If you know any method or anything strikes you, please say it. Please say the answer, right? So how will I do this? Now, next step is to add something so that it comes on the first carbon. So how can I add? Now again, I will add HBr in presence of
and peroxide.
peroxide. So what will I get? CH3, CH2, CH2, Br. So now you got a Br on the terminal carbon. Now how can I replace Br with OH? Aqueous KOH. Now this reaction is very interesting because first we use alcoholic KOH for dehydrohalogenation, and then we use aqueous KOH to remove Br and replace by OH. So there's a difference between the reactivity of KOH. If it is in alcoholic medium, it brings about dehydrohalogenation. And if it is in aqueous medium, in presence of water, then it brings about substitution reaction. It brings about substitution reaction. All right. Now isopropyl alcohol to iodoform. Now this reaction, I am leaving it for the time being because this reaction is better done when you have done alcohols, because I don't want to load you with these reactions right now. You will anyway learn them with alcohol. So let us leave it. Chlorobenzene to para-nitrophenol. Chlorobenzene. From chlorobenzene, I have to make para-nitrophenol. Okay, so what will I do first? I can do first nitration. How do I do nitration? HNO3 and H2SO4. So since Cl is ortho-para directing and it is deactivating, so para product is a major product. Ortho also can be formed, but mainly para. Now this para-chloronitrobenzene, I can change it to by replacing Cl with OH. How can I replace Cl with aqueous KOH? But here I need a little high temperature and pressure, because this bond doesn't break easily. However, presence of nitro group helps, but still some high temperature and pressure is required, and so OH will be replaced by aqueous KOH can replace Cl with OH. Okay.
Ma'am, can we do this by NaOH? No?
Yes, you can do with NaOH, KOH or NaOH, anything. In fact,
Okay.
NaOH is better. You can do with both. Then 1 bromopropane, 2 bromopropane to 1
Ma'am,
bromopropane.
can you for a second go to the before slide, ma'am?
Yes.
Yes. Okay. Yes.
Now this one I will not tell. Whoever finds the answer first, you speak out the answer. 2 bromopropane to 1 bromopropane. Anyone who can find out the answer, just speak. Let me see who gives me the answer first.
HBr with peroxide.
Where will I put HBr with peroxide? To what do I add HBr with peroxide? Good, you have understood
No,
HBr. If I add,
because
add
HBr and BR is already existing, ma'am. So can we add HBr? Is it correct?
you can't do HBr here. It will not react because already
Yes, ma'am.
this is saturated compound. So I need to first get rid of this. No, so how will I get rid of it? Anyone think?
Alcoholic
Yes, not KCN, alcoholic
KOH.
KOH, right? So what will I get? Propene. And once I get propene, then what can I do? Who was telling me the answer? Was it Hari Raghav?
Ma'am, yes, ma'am.
Okay. So HBr and peroxides. All right. Next one is chloroethane. Now they are doing repetition. 2-butane. Now Hari Raghav will not answer. Let me see who else can answer this one. And Vaishnavi also should not answer. Somebody else. Hariharan, you are a little quiet today. What happened?
Ma'am,
Hmm.
we can add another CH3, CH2Cl, then 2Na, ma'am.
Very good. 2Na and 2CH3Cl
Yes,
in
ma'am.
presence of dry ether. Perfect.
What's reaction?
Woods reaction. Very good. Woods reaction. Perfect. Now 1 bromopropane to chloroethane. Okay. Benzene to diphenyl. I'm writing benzene like this so that you can understand the product easily. This is diphenyl. How will I do this one? Sanjay, since you have missed one class, no, that's why you are not able to answer, but please revise.
Yes.
Otherwise, Sanjay, what you should do is you should request your coordinator. Then I can take one extra class for
No, ma'am,
Sanjay.
I'm comfortable with the recording itself, ma'am.
Yeah, please see the recording. Please look at the record.
Yes.
Tell me now, how can I do this? Anybody? When I had this one, I made it double by Woods reaction, right? Now here I can make it double. Here it is double. But for making it double, what do I need to do? I need to first have a chlorine here. So from benzene, can I make chlorobenzene? How can I make chlorobenzene from benzene? By adding Cl2 and AlCl3, anhydrous AlCl3. So if I do chlorination of benzene, 1 Cl will come on the benzene ring. And if I take 2 molecules of this and Na and dry ether, I will get this compound. This is called diphenyl. All right. Now this reaction is similar to Wood's reaction, but we give it another name. We call it Fittig reaction. So the Wood's reaction, when it is applied to haloarenes, it becomes Fittig reaction. Okay, Wood's reaction and Fittig reaction. So Wood's reaction is when there are haloalkanes, and when they are haloarenes, it becomes a Fittig reaction. Now let us take the next slide. Now we have benzene to diphenyl. No, that is done. Tertiary butyl bromide to isobutyl bromide. So tertiary butyl bromide, first you should be able to write it correctly. This is tertiary butyl bromide, right? And from here, I need to prepare isobutyl bromide. CH, CH2, Br. Now, how are we going to do this? Anybody? Vaishnavi, this is your favorite question. Tell me.
Ma'am, first we have to remove bromine, ma'am.
So using
So
what?
addition of alcoholic KOH.
Yeah, alcoholic KOH. So elimination of bromine will take place and I will get 2-methyl propene, right? And then I have to again add HBr, but this time in
Br.
presence of what? In presence of peroxides. All right. If I don't add peroxides, I'll get back the same compound. So by addition of peroxides. Now the last one here. This is aniline. Again, we are coming to aniline. And from aniline, we have to make phenyl isocyanide, NC. So first, you have to convert aniline. There are 2 steps. I will show you the and here N2 plus Cl minus. So these are this is the road. Now what reagents will help you to do this is what we have to write here. So here what are the reagents? It is NaNO2 and HCl and 0 to 5 degrees. Here what will I do? Here I have to add CuCl and HCl. So I'll get chlorobenzene. And from chlorobenzene, Hari Raghav had answered this question in the assignment. Tell me, how can I replace Cl with NC? Can you tell me?
Ma'am, by cyanide, ma'am.
Which cyanide? You
KCl.
cannot not potassium cyanide. This time you'll have to take silver cyanide. You remember answering the question why you get isocyanide with silver cyanide? Because CN is an ambident nucleophile. You have written it correctly in your assignment.
Okay, yes, ma'am.
So AgCN converts CN to NC. Okay, not CN. but NC. Shall I move on? This one also, I would like to leave it for the time being, because there are certain reactions which I haven't taught you, so I cannot, you can't answer this now. So I don't want to start those reactions. These also you will understand when you do alcohols better. Ethane to bromoethane. This is easy. Bromine in presence of diffused sunlight. When you use alkane and diffuse sunlight, a substitution reaction occurs. So that is how you do this reaction. Next is propene to 1-nitropropane. Now you have to put a NO2 group. So first thing, you have to introduce some halogen on the first carbon. So the only way you can do it is with HBr and peroxides. So you get CH3, CH2, CH2, and Br. Now you already got the alkyl halide. So if I use AgNO2, I will get the nitropropane. So this is 2 and this is 3. Now the fourth one. Children, all these are from your textbook. So I have chosen them from your, I've taken your textbook because in case you have a test in the school, they are only going to pick up questions from here. Toluene to benzyl chloride. Now this is toluene. Toluene is methyl benzene. This is toluene. And from toluene, you have to make benzyl alcohol. What is benzyl alcohol? CH2Cl. OH. Okay, OH not directly on the benzene ring, but on the carbon. So one hydrogen from this has to be replaced by a halogen, and then we can. So what is the road? First, I must get CH2Cl. Now you have to find the reagents which can bring about this change. So here I will do simple halogenation chlorine in diffused sunlight. Right? Substitution reaction. Hydrogen is replaced by Cl. And then what is the next one? Can somebody tell me? Hari Raghav or Hari Haran? Anyone? How can I replace Cl with OH?
Ma'am,
Ma'am, with
aqua-
first
Mhm.
KOH.
KOH.
Aqueous KOH. Very good. Aqueous KOH. The last one here, propene to propine. So CH3, CH double bond CH2. I have to change it to propine. This I will help you. First you add addition of bromine. So if I don't add sunlight and instead of bromine I have say CCl4, right? Then bromine does not do substitution, it just does addition. Okay, so what will I get? I will get CH3, CHBr, this is addition, CH2Br. I can add bromine. And now I use alcoholic KOH 2 times, right? First, this bromine and this hydrogen will go, and then this bromine and this hydrogen will. So what will I be left with? I will be left with propine, CH3, triple bond CH. So if I take vicinal dihalides or geminal dihalides and I treat it with alcoholic KOH, then I can get alkynes. Hariharan, have you done all these things in the school also, like all these conversions? Has your teacher helped you in the school?
Yes, ma'am. Yes, ma'am.
Okay, very good. Now, let us do this one also. CH3, CH2, OH to 1-butene. Since I have already given you the half the method, you should be able to do. Now tell me. How can I convert this to this one? 1-butene is which one? Let us write the formula. It is CH3CH 2C triple bond CH. This is 1-butene. Okay. Now can you tell me how we will do this?
ma'am, first by adding aqueous KOH, ma'am.
Why? We have ethanol. What will aqueous KOH do? First, we have to remove OH with Cl. So we'll add PCl5, isn't it? CH3, CH2, Cl. That is what you are looking for, isn't it?
Yes, ma'am.
Then you increase the number of carbon atoms with 2Na and ether, right? So what will you get? You will get butane, CH3, CH2, CH2, CH3. Right? And then let us do chlorination in presence of sunlight. Then what will happen? One of you have made an error in this question in the assignment. I don't remember who, but just see this. When you do chlorination, it is always, if there is primary carbon and secondary carbon, the hydrogen, which is the secondary carbon, will be substituted. So if I continue substitution, Cl will come in this. 2 hydrogens will be replaced by 2 chlorines. And now if I use alcoholic KOH, I will get 2-butene. All right, I can get 2-butene. The 2Cl can be on the same carbon atom or on adjacent carbon atom. In both cases, you get an alkyne. Okay, so that is. Now let us do the last page and then we can just take the list of reagents. Okay, Now ethanol to ethyl fluoride, CH3, CH2, OH. To ethyl fluoride, CH3, CH2, F. Tell me. Any one of you. Some of you know it all well. So tell me quickly. It is just a revision for you.
Ma'am, can we do it in Schwartz reaction?
Huh? Schwartz reaction, yes. We will have to do the Schwartz reaction, but Schwartz reaction requires what? It requires a halogen, isn't it? So how can I replace OH with C?
Fine.
Yes, ma'am. We can't do this.
Yeah, PCl5. So I can write CH3, CH2, Cl. And now we can use the Schwartz reaction, right? With AgF,
HF, ma'am.
right?
Yes, ma'am.
Now the second one. This is the first one. Now the second one. 2-bromomethane, 2-propanone. Bromomethane. This is again a long one. So this is 1 carbon atom and this is 3 carbon atoms. So it will take time. Anyway, let us try. 2-propanone. Here again, I think I would suggest that we will leave this because unless you do alcohols, you can't answer this question because you can get 2-propanol, but 2-propanol, 2,2-propanone, you will not know. So let us leave it. Have you done this, Hariharan? Have you done this in school?
A Schwartz reaction we have done, ma'am. Schwartz reaction and PCl5 we have done, ma'am.
No, I am talking about bromomethane to propanone.
Bromomethane to propanone.
Have you done that one? Do you remember?
To ketone, I don't remember, ma'am.
Yeah, so this one generally it is a little, we can do it because we haven't learned methods of preparation of ketones, so we can leave it for the time being. Now let us do but1-ene to but2-ene. This is easy. To but2-ene. How can we do that? Anyone?
Ma'am,
Right? How
addition
can
here.
HBr, addition of HBr or HCl, anything you can do. And then how can I get back this alcoholic KOH? Now this reaction without my writing and this reaction without my writing, this is a repeat. This reaction without my writing, you know what is it? It's a Woods reaction. Right? Because here there are 8 carbon atoms, here there are 4. So 4 into 2, 8. So it has to be doubling. So whenever that is doubling, it is Woods reaction. Here there are benzene to biphenyl. This has to be Fittig reaction. But remember, in this case, benzene should first change to chlorobenzene and then to biphenyl. Okay, so that is. Okay, so now we have
Biphenyl.
Benzene to biphenyl. Biphenyl, I just explained to you. It is 2 benzene rings attached together by a single bond. This is known as biphenyl. So first convert benzene to chlorobenzene and then this one. Okay. now children, the last bit, and after this, I would like you to only ask me the doubts. In the next class, I am planning to, like tomorrow, I am planning to start with solutions. Do you have any other suggestion in your mind what you want to do, or shall we just start with solutions? Like today's class, was it helpful to you? Because after finishing the portion, I thought revising it is always very important. Was it useful?
Yes, ma'am.
Okay. So now what we'll do
Yes,
is
ma'am.
we will just make a list, and I want you to, after this, go through all the questions in your textbook, other than the assignments. Go through all the questions in the textbook and try to solve them. You will get an assignment today on this whole chapter also. So you can, they are mainly MCQs. So you can go through the MCQs also. Wherever you have doubt, please mark and keep. So tomorrow we'll first address your doubts and then we will start with the lesson. So now I want you to make a list of important reagents, right? This will help you in all the topics of organic chemistry, important reagents. Okay. Now the first important reagent is aqueous KOH. What does it do? It changes Cl to OH. Second is alcoholic KOH. Okay, it changes, it removes HCl, and what does it do? Forms forms a double bond, right? Minus HCl by removing hydrogen and chlorine. Then the third important reagent is NaCN. What does it do? It replaces Cl with Cn. The fourth one is AgCN. What does it do? It replaces Cl with Nc. The fifth important reagent is PCl5. It replaces OH with Cl. You can use PCl5, PCl3, SOCl2, anything. HBr or HCl without peroxides. It will show Markovnikov addition, right? For example, propene plus HBr in without peroxides, it will give CH3, CHBr, CH3. The seventh one you should remember, only HBr and peroxides. What does it do? Anti-Markovnikovs. So what will it do? CH3, CH double bond CH2 plus HBr in presence of peroxides. It will give CH3, CH2, CH2Br. Did you all note it down or you want? Next is 8th one. It is AgF. What does it do? It replaces Cl with F, right? This is Schwarz. Then 9th one, NaI plus acetone. It replaces Cl with I. This is Finkelstein. Then 10th one. Sodium and dry ether. It is 2Rx plus 2Na. It doubles RR you get. This is Woods. And the second example here is benzene, chlorobenzene plus 2Na. It will give biphenyl. This is phytic. Then O RONA. What does it do? It replaces Cl with OR. AgNO2. It replaces Cl with NO2. RCOOAg. It replaces Cl with COOR. This one will form ethers. This one will form ester. This one will form nitroalkanes. And the last one is H2O and H plus. What does this do? It will convert Madhavan. What will this do? CN2. You answered this question already once. I have asked you only one question. What does H2O and H plus do? It changes CN2 COOH, right?
Yes, ma'am.
So now my suggestion to all of you is, these are 15 reagents which will help you to remember all conversions, everything which happens in alkyl halides. So write them on a piece of white paper and stick it in front of your table and keep seeing it all the time. You will get photographic memory. When you think, that clear thought will come to your mind. Okay. We have not done the reagents with now we will take one more page and we'll do the reagents for haloarenes. So the 5 more reagents for haloarenes. So this is NaNO2 and HCl 0 to 5 degrees. What does it do? It replaces NH2 with N2 plus NCl minus. 17. CuCl, CuCl and HCl. What does it do? It replaces N2 plus Cl minus with Cl. What does ammonia do? NH2. What does NH3 do to ammonia? NH3. This also we have done. NH3 at 350 degrees Celsius. It replaces Cl with NH2. Even in haloarenes. Then 19 chlorine and AlCl3. Remember these reagents. It will replace H of the benzene ring with Cl. 20 HNO3 concentrated plus H2SO4 concentrated. What does that do? It replaces H of the benzene ring with NO2. Okay, so these are haloarenes. All those things which you think you need to note, you can take a screenshot when you see, you can review the recording, you can take screenshots and keep them, or best is to take down notes. Organic chemistry in the first class itself, I told you, it is very easy when you hear it. The difficulty is when you have to recall it and reproduce. So for recalling it, you have to write and write and write. If you can write these 20 reagents from memory in the next 2-3 days, then you are done with alkyl halides. It's not a problem. Okay. Now there are other type of questions for which I am not spending time in this class, but you should be able to do them. That is, you should practice, give reason type of questions. Okay. And also you have in give reason type of questions, all those SN1 and SN2, that comparison of long answer questions are from there, SN1, SN2. And also you should learn in all those SN1, SN2 come in MCQs also. So I hope today's assignment that you get, it will contain maybe some SN1, SN2 type of questions. Please answer and note down all those questions which you don't understand. We can practice it tomorrow. Okay. So see you all tomorrow. Thank you for patiently listening and
thank you,
also
ma'am.
keeping your camera open and participating. Right? The more you participate, the more interesting the class will become. Otherwise, I am a very senior person. I can't make, see, like I know that some people take more lively classes, like, they will keep saying so many nice jokes in between to keep you alive. I'm not able to do that for some reason. I take class very seriously, and so the class becomes a little serious sometimes. So, but anyway, thank you for all your cooperation, and see you tomorrow. Okay, bye.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
You're
ma'am.